Welcome to EDU World Space.
So I've written some of the problem information here. N sub c is the number density of conduction electrons in the metal plate of the capacitor. So that's the number per unit volume of mobile electrons that are free to move from the bulk to the surface. And we're also given an example of depth from which conduction electrons can travel from the bulk to the surface and associated applied voltage across the capacitor plates of 20.0 volts. And we're asked for the ratio of capacitance to area. Now, to get capacitance, we want the charge over the voltage. We're given the voltage, so we try to find the charge. And to find the charge, we consider one plate of the capacitor like this, close up, with the right side being the boundary. Conduction electrons travel from a distance maximum of ds to the surface. And so the charge accumulated on the surface will simply be determined by how many conduction electrons are in this volume next to the surface of depth ds. So the charge accumulated on the surface, neglecting a negative sign, is just going to be the charge on each conduction electron times the number of conduction electrons in this volume near the surface. And that's going to be the number density times the volume, and the volume is the depth, times the cross-sectional area. And since by definition of capacitance, this is C times Vs. And so we can just calculate the capacitance from the definition Q over V, and we can get the capacitance per unit area. So C divided by A is equal to, and now we just have to plug in the numbers. Electron charge in SI units is 1.602 times 10 to the minus 19. Number density is given. And depth is also given as 1.00 picometer. And we're going to divide all that by the voltage applied. So this is really surface charge density divided by voltage, and that gives capacitance per unit area. So if you plug in all these numbers, you find that you get 6.80 times 10 to the minus 4. And since we're always working at SI units without any powers of 10 now, this is farads per square meter.